Everybody can see the slide?
Tak ada sir.
No.
Belum screen.
Ai, dah hilang. Oh, I supposed to click no, I click the stop. Okay, Bismillahirrahmanirrahim. So this is the interesting topic. So where we can investigate the basic knowledge about the motor, the induction motor. However, we should cover the AC, the fundamental of the AC circuit, but it's okay because the induction motor mostly quite similar with the transformer. Okay. Wait. Okay, Bismillahirrahmanirrahim. So yeah, let's go through to the induction motor. Okay, so these are the outlines of this subtopic. So yeah, they start with the introduction, okay, induction motor construction, then the basic induction concept until the induction motor rating. So inshallah today we will cover until 3.4, the subtopic 4, which is the power and torque in the induction motor. So however, the power and torque in induction motor we will cover in the video, not in this Google Meet. Okay. So this is the good videos, the good videos for more understanding and very detailed explanation. So I also study from this guy, and very helpful, very good, very interesting. And you can try to look at this video later on. Okay. So as usual, so this is the video for the encourage your study. Okay, so the single construction, the induction motor construction. So yeah, basically there are two types, the single phase and also the three phase induction motor. Okay. Alamak. Okay, mana sekejap wait Oh, belum pula penulisan ni. Sorry. Okay. Yeah. Okay, so there are single phase induction and also the three phase. Okay. So yeah, same as a normal motor where there are two types, which is the stator and also the rotor. So rotor is the rotating part, and the stator is the stationary part. Okay. So as you can see here, the induction motor is the most frequently used motor in the world. Okay, so majority of the industry use this type of motor. The most important question is why they are using it. Okay, you can see even in our home appliance, machine, washing machine, refrigerator, and so on, they are using the induction motor. Okay, the reason is because of their simple construction. Okay, the induction motor is a simple construction and then highly reliable. Okay, and the last and very important point from the industry is the economical. Is a low cost, okay, and also low maintenance. Okay, so this is the main point. I can see this is the 3 point, highly reliable and also the economical. So this is the main reason why this kind of motor very common in industry. Okay, so there are, yeah, this is the I can say this motor. Yeah, mostly in the industry, when you go, you can see here, even in the, if you can go to the market, macam pasar kan, go to pasar, you can see the machine for santan. Machine for santan, you can see this kind of motor. Okay, you can see this kind of motor. Okay, even in the yeah, compression the kelapa, coconut, to get the santan, they are using this kind of motor. Okay, so why they call it induction is because of the induction, the rotor voltage. Okay, the rotor voltage is induced in the rotor winding. It is similar with the transformer, where the transformer we have the winding kan, boleh rasa macam ni. Okay, and this is the second winding. So when there is a flux, so they cut through the coil, so there is a induced voltage. Okay, induced voltage. So same goes to the induction motor. So actually there is no connection between stator and also the rotor. Okay, there is a gap actually between stator. This is the stator, the winding, stator winding, and also the rotor. So you can imagine like this. So this is the stator. Okay, and also the rotor. So there is a gap. Okay, so there is a gap. So you supply voltage to the stator, and the rotor inside will moving due to the induction of the rotor voltage. Okay. So yeah, for the generator very rarely so we will not cover about the generator. We will not cover the generator. So there are two types of rotor. The rotor, there is a squirrel cage and also the one rotor. So in this course we will cover only the squirrel cage. Squirrel cage is like it look like macam, pernah tengok tak apa? Alamak, apa nama dia? Macam tikus kan, tikus yang ada sangkar dia, lepas tu dia ada tempat dia lari tu. Kena ni batang. So tikus tu lari, so dia berpusing. Can you imagine that? Boleh imagine tak?
Mainan hamster.
Hamster. Mainan hamster tu. Okay, so squirrel pun dia guna benda yang sama lah. Okay, so it's look like that. So the motor use the squirrel cage rotor because of the robust and also the maintenance free construction. So this is kind of the squirrel cage benda ni this is squirrel cage. So dia tak ada connection between stator and also the rotor. Asal ramai keluar masuk internet problem. Okay, so yeah, this is the squirrel cage. Okay, squirrel cage. Kita tengok di sini dia skew dia bukan directly okay, dia bukan directly tegak je connect dia ada skew, little bit skew okay. So this is a laminated iron core So dekat luar dia ada laminated okay, dia banyak laminated tu. Satu kan. Okay, and you can see here this is a little bit skew okay, macam skew sikit lah. Okay, Okay, there slot inside. Okay, kalau kita boleh tengok kat dalam dia, dia lebih kurang macam mana nak cakap dia macam ada bulat lah dalam dia. Okay, so there are a lot of slot lah. Okay. Okay. So then there is a mounted in the shaft shaft dia lah. Okay. So normally the connection between the body the body and the connect with the body, the shaft connect with the body through the bearing So there is a bearing Okay, bearing. So the bearing will be very good Okay, depan belakang ada bearing Ada bearing So without bearing, so the motor will not move smoothly Okay. So since you use a bearing, so yeah, sometimes bearing they have a lifetime Okay. So kalau rosak pun normally bukan motor yang rosak, tapi mungkin bearing yang rosak Okay, so the aluminium bar are mold in the slot. So ni kat sini dia model, dia mold dia ada molding process So itu cast iron punya process Okay. So okay, and then the slot dia punya bar ni dia short circuit between this part and also this part Okay. So why they are closed loop? Because they want to allow current to flow. Okay, they want to allow current to flow. So without closed loop, there is no current flow, and when there is no current flow, there is no force and there is no torque, and that means there is not moving. Okay. So the bar are slanted or small rotor reduce the audible noise And then kalau kita tengok kat sini, dia ada macam ada gigi kan, ada macam fin dia panggil macam ada fin kat sini kan, fin ni kan. So ni adalah act as a fan Okay, they act as a fan because to reduce the losses Okay, ni losses so they to improve the cooling system Okay. So this is the type of round motor where there is a three they call this apa nama ni, ada slot kat sini So the connection dia macam DC brush motor quite similar with the DC brush motor So they have a brush here and connected with the stator Okay. So when they connect with the stator, so the current will flow and then they will induce the force and torque Okay. So at apa nama ni, subhanallah, the squirrel cage, there is no connection between stator and rotor Okay. So later on you will see this one Okay. Okay, I would like to share a few things first. Let's create a new slide. Okay. And present it. Okay. So imagine the stator So this is the stator. Tak ada pun. Okay, this is the stator. Okay, tak nak bulat. Tak apa. Dia dah lag benda ni. Alamak. Sorry dia lag. So dia dah terabur sikit. Okay lah ni So dia ada winding So winding dekat winding at the stator Winding at the stator I think, okay, just imagine round, and sorry, there is a rotor. So when there is a current flow into the stator, so the stator will generate rotating magnetic field. Okay, rotating magnetic field. Okay, so imagine like this. Wait, I try to change the color. Okay, this is the magnetic field. Magnetic field that produced by the stator. Okay. Just imagine, there's not necessarily like this exactly. So just to make you easy to understand. So magnetic field, stator. Okay, so in this direction, okay, and the direction of the rotating magnetic field is in this direction. Okay, omega s. Okay, so this is a very important information. So basic knowledge about the induction motor. Okay, so we take one slot. Okay, so change the color. So we just take one slot. This is the slot, winding over here, and then there is a magnetic field. Okay, just take like this, magnetic field. Okay, and moving in this direction. Okay, so actually in previously we study about the current generation in a wire. Have you still remember in the chapter 1? Still remember the current producing in a wire? Apa tajuk dia? Wait, there are three, if I'm not mistaken, three subtopic. Okay, so one is the production of induced force on a wire, and then induced voltage on the conductor moving. Okay, induced voltage on a conductor moving in the magnetic field. Still remember tak? Dah tak ingat lah. Ni nak tanya ni soalan dalam test. Alamak, kantul pula, bocor pula rahsia. Okay, so soalan macam ni dia akan keluar lah dalam test. Okay, the test will ask you about the induced voltage on the conductor moving in the magnetic field. So there is a magnetic field, and then the magnetic field is moving. Okay, so what happened to the wire? Okay, so when hilang pula. So when there is a magnetic field moving, so what happened to the wire? Okay, and what is the direction of the velocity? Okay, so in order to get the velocity, we will look at the relative motion, okay, or the relative velocity. Okay, so the magnetic field will move. Okay, the magnetic field will move with the n synchronized, which is the speed synchronized. Okay, where the formula is 120 electrical frequency divided by number of pole. Okay, so this is the in the RPM, this is in the radian per second. Okay, angular velocity. Okay, so what happened? So in order to get the velocity, okay, the induced velocity, okay, the induced velocity actually come from the relative speed or relative motion. Okay, so what is the relative motion? Any idea what is the relative motion? Tak ada idea. Okay, so the relative motion actually there should be a comparison between two things. Okay, two side of perspective. Okay, one like this macam when you drive a car. Okay, when you drive a car, you actually moving forward. Okay, you are actually moving forward. Okay, when you are driving and then someone look at the top. Okay, someone look at the top and they see your car actually moving forward compared to the environment, compared to the environment lah, pokok apa semua sekali, the trees. Okay, so when you look from the stop, you see your car is moving forward. Okay, but when you look at your own perspective as a driver, are you see that the car is moving forward, or you see the environment moving backward?
Environment backward.
Environment moving backward, right? So this is a perspective lah. Okay, at some point you tengok sini. Okay, when you look at this perspective, they are moving forward, and at the different perspective, the thing is moving backward. Okay, so kalau dia moving in this direction, angular velocity in this direction, so the velocity or the angular velocity pula, the velocity will move to which direction? So kalau ni yalah, kalau velocity kan, so velocity kalau kita ambil, dia akan bergerak sini lah, betul? Okay, ni Vs lah, betul tak? So kalau relative motion, dia punya speed belah mana? When, yelah, bila kita tengok the relative motion tu, dia bergerak belah kiri kan? Okay, tapi bila kita tengok relative motion, dia macam oppose, lah. So dia moving into this direction lah. So this is the V induced lah. Okay, so ni dah tak pakai lah Vs ni. Tak boleh nak padam pula. Okay, so okay, now we have the B and S. So if we look at we back at the chapter 1, what we can find? When there is a V and also the magnetic field B. Okay, what is the formula? Siapa yang ingat? Okay, so the production of the dia punya tajuk tu adalah production of the induction voltage on the conductor moving in the magnetic field. Okay, so dia punya formula adalah V induced. So E induced is equal to velocity cross product with the B times with the L, length of the conductor. Okay, so ni conductor ni belakang dia lah. Ni, you boleh imagine lah, conductor ni kan squirrel case tadi tu. Okay, so what happened? So E induced is equal to V cross B. V cross B, we use the right hand rule lah. So the thumb, okay, so macam nak cakap, so the thumb is moving. So ni tangan kita grab lah. Okay, tangan grab. Okay, so and this is our thumb lah. Okay, so the current will flow macam mana ni? Outside the paper outside the paper. Okay, so outside the paper. So once the siapa mesin ni? So once the at this point contohnya at this point outside the paper, and since this side and the back side is closed loop, so you can imagine that at this point they will come in they will go to the paper lah, So dia macam bulatan lah sini. Okay, dia anggap macam bulatan lah. Okay, ada bulatan kat sini. Dia macam close loop lah, macam tu. Okay. Okay. So boleh faham tak setakat ni? Boleh faham tak? Hello?
Boleh dok. Boleh.
Boleh So okay, so sekarang dah ada current. So now the current is induced. So once there is induced current, what happen? So kita dah belajar ni chapter 1. Okay, so in the chapter 1 we also study about the production of the induced force on a wire. Okay, so ada force equal to, kita buat macam ni kan, the cross product kan, I dengan B times dengan L, betul tak? So since since I is upward, so kalau kita buat macam ni so this is B and this is I. Okay, so cross product I to B, so this is force lah. Okay, so this direction is force. So the force will produce in this direction. Okay, so once the force is produced in this direction, so you can imagine so this at this point force like this, at this point force like this, so like this. So for this point, so dia terbalik lah, because the current flow terbalik kan, so current flow terbalik ke belakang, so dia moving like this lah. So everything will move, force produce like this lah. So, boleh imagine So all in will be in the same direction lah. So which is the kalau daripada sini kita tengok dia counterclockwise So kita tahu force time dengan radius, they will get the torque. Okay, so that is the how motor is moving macam tu lah So and then the torque will move into same direction with the angular velocity of the stator magnetic field Okay, so itu adalah dia punya fundamental lah, macam mana okay, from the generation from the generation of power supply, from the power supply, so will generate the current C pula, will stator current, okay, stator current, and then they will produce a magnetic field, and from magnetic field it will produce they will induce current voltage, and then they will generate current. Okay, ni rotor okay, and then they will generate force, and force will generate torque. Okay, so this is the flow Okay, so later on you can easily understand Okay, so this kind of principle must be remembered so how the basic of kita study what we study in the first chapter, so they will we will use that to the for the chapter. Okay, so this is another explanation about the torque produced in the induction motor. However, this kind of explanation is more suitable with the wounding motor, but it's more easy Okay, for imagine you supply 3-phase voltage. Ada orang nak tanya? Meta Ganesh. Ada yang angkat tangan? Nak tanya ke apa?
Sorry doktor, silap tekan.
Okay. So imagine you apply a 3-phase voltage to the stator, and then a 3-phase current flowing to the stator and produce the B, as I mentioned before. Okay. So imagine this is the direction of the magnetic field of the stator. Okay, so and the magnetic field is moving with the speed of n-sync, they call it n-synchronized. Okay, so this will come out with the unit of RPM. Okay, because it's n. Okay, 120 times with the frequency of electric. So based on your macam rumah punya frequency lah. Okay, and then the pole, the number of pole. So later on kita tengoklah apa number pole ni. Okay, and then they will induce the maximum voltage. Okay, so this is, as I mentioned before, they will induce a maximum voltage. Okay, so yeah, this is the direction of the magnetic field lah. Okay, so and then once they produce, they induce the voltage. So the voltage will induce the current. Okay, so yeah, from this direction, from this you can see this is the voltage and this is the current. Okay, this is the I. So why you can see why there is a lag. Okay, current is lag. So because normally the current is lagging. Okay, normally current is lagging. Okay, this is the IR. So where this is the induced current, and then the induced current, so you can imagine so this is, dia macam bulat tau ni kan, dia apa, subhanallah, dia close loop kan. So bila dia close loop, dia moving like this lah. Okay, ni keluar, ni masuk, so current will flow like this kan. So when we use our right hand rule, so when there is a current flowing to the coil, so they will produce a magnetic field in this direction. Okay, in this direction. So B induced. So this is the BR. Okay, B of the rotor. Okay, this is B rotor, and then there is a, when once there are BR and also the BS, there will be a one magnetic field, B net. Okay, and this is the ER, the voltage at the rotor. Okay, later on we will see at the equivalent skirt. Okay, and then there also the phase over there. So BR and BS rotate at n-sync. Okay, but rotor turns at a slower speed. Okay, so normally the rotor will move slowly, not slowly, slower compared to the n-sync. Okay, so the rotor speed, they call it as a Nm. Okay, this is the rotor speed. Okay, in RPM. Okay, so this is the induction of the induced voltage, induced torque. Okay, so this is more easier. So when there is a BR and BS, okay, they like this is like a cross product. Okay, but this is the direction of the cross product. So that is the direction of the torque. Okay, the torque induced, same like a previous. So I think the previous explanation is much more clear compared to this one. Okay, so this is the explanation. Whatever I said, this is the in term of text. Okay, so ada three phase winding, and then there will current flow. Okay, the producing a rotating flux. Okay, so the stator flux rotate at the synchronous speed. So this is the formula, and magnetic field passes conductor on the rotor and induce a voltage. Okay, so when there is a short circuit and then the current will flow. Okay, so you can imagine kalau macam transformer kan. So at the secondary part tu dia open circuit. So tak adalah, there is no current flow. Okay, when there is when there is, at the secondary part is short circuit, so the current will flow. So same goes to here. So current will flow to the rotor when there is a short circuit. Then rotor current produce. So when there is a induced current, and the current will produce a magnetic field. Okay. So which act to oppose the stator magnetic field and also rotate at the synchronous speed. Okay. With two magnetic field rotating, so ni dia punya torque lah. So generation of the torque. Okay. Dia kata ni rotor flux density will lag. Okay. So sebab tu dia punya current lag by 90 degree. Okay. So the torque will be in the same direction as the rotating magnetic field. Okay. So okay, ni seronok sikit. So the torque accelerate the rotor until synchronous speed. Okay. Until synchronous speed. So what happened? Rotor move in the same direction or in the same speed as the end speed. So what happened? N sync terbalik ni. NM rotor speed same to the N sync. What happened? Agak-agak apa jadi? So bila this thing happen, once this thing happen, there is no relative motion. Okay, because same direction, same speed. Okay, macam tadi kan pokok dengan kereta, car and the car and also the environment moving in the same direction at the same speed. Okay, so there is no relation, no relative motion. Okay. So between the conductor and also the stator flux density. So since the relative velocity is 0, okay, so the induced voltage is 0. Induced voltage, rotor current, flux density all to 0. And torque is also 0. So apa jadi? So dia macam stability So bila dia dah sampai maksimum, dia punya current, voltage semua dia akan stop. So dia akan, motor akan mula stop, mula slow. So motor will move slow. And then once there is a relative motion again, so they will upward again. So like this, lebih. Okay. So however, the rotor speed will never reach the synchronous speed. So they will try to catch. Okay, the rotor speed will try to catch the end sync. Okay, so this one will never happen actually. Will never happen. Okay, so kalau dia dah happen ni macam ni, motor dah slow motor dia dah jadi tak efficient So dah tak ada induce semua tu dah tak ada, and then dia akan jadi something wrong. Okay. So in the normal operation, both of the rotor and stator magnetic field, so BR and also the BS rotate together at a synchronous speed, while the rotor itself turn at a slower speed. Okay, macam dah sebut tadi. Okay. Okay, so then we will move to the concept of the rotor slip. Okay. So the voltage induced in the rotor bar depend on the speed. Okay, so ingat tadi so kita ada yang tadi tu kita ada B and then kita ada V. Okay, V ni dia punya speed Okay, dia bergantung kepada speed. Okay, barulah dia ada F tadi. Okay, so the voltage induced in the rotor, yang tadi kan, yang ada betul ada I kat sini kan. So I, so bila ada I adalah dia punya E tadi tu. Okay, So the voltage induced in the rotor bar depend on the speed of the rotor relative to the magnetic field. So there are two terms to define the relative motion. One is the slip speed and the other is the slip. Okay, so slip speed actually is the difference between the synchronous speed and also the rotor speed. So just a difference, okay, the difference only. While the slip actually is it's like a ratio, relative speed expressed. So this kind of thing, when we replace this, okay, we try to replace this, what will happen? Let's see. Okay, so from here we can see something with the equation. So this kind of equation normally used in the percentage. Okay, kalau kita darab 100 je, so dia dah dapat percentage lah. Okay, so ini cara calculation lah. Cuma the S actually is not at the percentage. Okay, but sometimes in the equation they will give you in the percentage. Okay, so when they give you in the percentage, you just divide with 100 lah. Okay, so we can also express the slip with the radian per second, actually the angular velocity. Okay, while this is in the revolution per minute. Okay, RPM. So this is in the RPM form. This one is the angular velocity. Okay, angular velocity. This is the radian per second. Okay, radian per second. This is in the RPM. So from here and slip, the unit actually is the RPM. Okay, the unit is RPM, while slip there is no unit because RPM divided by RPM is equal to no unit, unitless. Okay, and then we can simplify the NM, the relation of motor speed, rotor speed with the n sync by using the this equation, which is the 1 minus S times with the n sync. Okay, because after this we will look at the slip and also slip speed. Okay, so from this previous equation, from this equation, what we can see? Okay, so you can see that if the rotor turns at the synchronous speed, okay, so for example Lm is equal to n sync. Okay, tadi punya equation Nm is equal to 1 minus S n sync. Okay, ataupun equation lain tadi n slip n sync minus nm. Okay, so notice that if the rotor turn at the synchronous, okay, rotor is this, the slip will be 0. Okay, so this one will replace with the n sync, so the slip will be 0. Oh, ni n slip, so slip n sync minus nm because divided by n sync. Okay, so when this is n sync, so the slip will be 0. Okay, so while if the rotor is stationary, so kalau motor tu tak moving, kalau motor tu kosong, tak bergerak, so when nm is equal to 0, okay, so for example this is 0, so n sync divided by n sync, n sync divided by n sync, so equal to 1. Okay, so however yeah, motor not moving, for sure it will happen, okay, because from starting and then S1 S equal to 0 normally will not happen. Okay, so in the ideal condition, yes, they will happen, but in the real not will happen. Okay, so all motor speed fall between these two limits. So there are two limits. Okay. So kalau kita tengok nanti dia punya movement tu, so kita tengok lah. So for example ni RPM. So ni NM. So NM, so sini kan kosong kan, starting kosong, and then this one is 100% lah. For example lah, 100%. So when there is a NM equal to 0, the S is equal to 1, while 100% mean NM equal to NC lah. Okay, so I just show in percentage. So at this point, so S will be equal to 0. Okay, so yeah, so the speed, motor speed will fall into this two region. Okay, in this area. Okay, so nanti speed dia mungkin ada yang macam ni ke, kita tengok lah lepas ni macam mana dia punya graph. Okay, so ni katakan I, so ni I max, so I will reduce something like that lah. Okay, so and then the electrical frequency. Electrical frequency, why that is important? Yeah, because the electrical frequency supply from the stator and then will convert to the rotor. So rotor tu kan ada produce current kan, so rotor tu ada produce current. So bila dia produce a current, so since we are using the AC, so since we are using the AC circuit, AC current, AC voltage, so the induced voltage also in AC. So therefore they will have the frequency. Okay, so is it the frequency similar with the supply frequency? Okay, we will see. Okay, is it similar or not? Okay. Okay, so induction motor also called as a rotating transformer. So transformer but in rotating. Okay, due to its induced voltage and current. Okay, the principle is the same. Okay, the principle is the same. So primary stator, which is the stator, and the transformer is primary side, and where the induction they call it as a stator. Induce the voltage to the secondary, where this induction they call it a rotor. However, unlike transformer, so frequency not necessarily same as at the secondary and primary. So not necessarily the same. Okay, for kalau frequency, kalau transformer maybe dia sama, tapi dia tak sama kalau induction motor. Okay, so now kita imagine if the motor is locked. Okay, kalau motor tu lock, which mean not moving. So not moving, Nm is equal to 0. So when Nm equal to 0, S is equal to 1. Okay, S equal to 1. So at this point, the frequency of the rotor will be the same as the frequency of the stator. Okay, so ada yang cakap lah kalau nak mudahkan pemahaman, kalau ada satu orang berdiri kat sini kan, okay, and then ada bulatan, so ni statik ni statik ni statik. Lepas tu ada someone else, dia gonna to slap this guy, but they must rotate. Okay, so bila dia rotate satu kali, dia sepak sekali. Okay, dia slap sekali. Okay, so one revolution, one slap. Okay, so kalau dia ada 60 slap, 60 revolution mean 60 slap. Okay, so kalau macam ni, so dia akan jadi apa kata, macam macam mana nak cakap ni, Dia akan jadi sama lah sebenarnya. And then what happen when this guy start to move? Okay, this guy start to move. Okay, so for example this guy moving 120 rpm Okay, so ni 1 rpm lah. 1 rpm equal to 1 slab. Okay, slab dah salah je. Okay, slab. So kalau dia move 120, which is in 1 minute, 120 slab. Okay, in 1 minute 120 rpm, so revolution per minute per minute. In 1 minute they will have 120 slab. Okay, what happen when this guy start to move with 60 rpm? Okay, when it start to move with 60 rpm, so this guy need to catch this guy lah, because dia dah moving kan, dia dah moving, not more static. Okay, so when there is static, so they will always go for 60 or 1 rpm 1 slab, 1 rpm, so static kan macam tu. So once they are moving, so they are moving 120 and the other guy moving 160, so dia dah ada 60 rpm. So tadi saya dah salah sikit lah. Okay, so katakan ni 60, so ni 30, so ni jadi 30. So tapi dia gerak sama, 60, ni 60, ni 60. Tapi disebabkan tadi tu static, so they will have 60. Okay, once this guy moving with 30 rpm, so the number of slab will reduce. Okay, so frekuensi tu dia akan reduce jugalah. Okay, same goes to here lah. So if the rotor rotate at Nm is equal to Nsync, so the frequency will be 0. Okay, for example this guy, okay, this guy moving with 60 rpm, same with this guy. Okay, 60 60. Okay, so they will never catch. Okay, because they are moving together. Okay, so dia takkan jumpa lah, dia ibarat macam takkan jumpa lah, nak point nak untuk slab. Okay, so the frequency will be 0. Okay, so the S is equal to 0. So from here we can see something. Okay, from here we can see something. So which is the F, R, dia boleh jadi macam ni lah, FE. So simple je sebenarnya dia nak cakap kat sini. Okay, so ini adalah dia punya formula. Faham tak? Ada any question? Hello?
Faham, Doktor.
Faham Ya ke faham? Macam tak faham suara tu.
Nampak soalan nanti baru.
Okay, ni just a explanation permulaan dia. Okay, tak apa, later on you will understand insyaAllah. Okay, so for any different speed, so yeah, for example, this guy, okay, this guy and the second guy different. Okay, so rotor and also the stator, they have a different of the speed. Okay, so for any speed between the rotor frequency is directly proportional to the different speed of the magnetic field and sync and the speed of the rotor. So ini kita dah tengok, ini adalah dia punya slip, this is the slip, and so we try to convert at this point, okay, which is the frequency of the rotor is equal to the slip of the slip multiple with the frequency of the electrical. So at this point kita boleh tengok N sync, so 120 FE divide by pole, number of pole. So kita boleh ubah lah kat sini. Okay, so N sync, so macam mana kita nak ubah benda ni? kepada Nm. Siapa boleh? Okay, katakan yang ni macam mana kita nak buat? Guna slip. Kita guna slip. I think guna slip je. Boleh tak? Boleh dapat gambaran? Okay, so yeah, from here we can get the FR okay, between this equation okay. So FR is equal to number of pole divided 120 times with the difference of the speed which is the ni apa nama ni, end slip okay, the difference okay, the end slip okay. So kita juga boleh tukar lah sebenarnya, ini FR ataupun NM kan, kita boleh ubah. So kalau kita ganti-ganti kan, kita akan dapat lah. Okay, so NM pula, NSync. Kalau kita cuba ubah dapat tak? Okay, and ini NM 1/S. Okay, yang ni ubah FE begitu 1/S okay, F 1/S, FR/S. So kita gantikan je lah, FE ni ganti kat sini, so yang ni ganti kat sini. Okay, so nanti boleh dapat lah. Okay, so this is the example of the calculation so let me open directly. Ni senang sikit lah. Dah ada kan. Nampak tak ni?
Nampak.
Okay. So the question is 220 volt 3 phase. Okay, ingat 3 phase 6 pole lah. So biasanya number of pole ni dia dah bagilah. Okay. Number of pole dia given with the 50 Hz induction motor is running at the slip at the 3.5%. Okay, so boleh perasan tak kat sini dia tulis dalam percentage. Okay, so 3.5 is the slip percentage okay, slip equal to divide by 100 lah. 1, 2, 1, 2, 3, 5. So this is the slip. Okay, so find the speed of the magnetic field. Okay, speed of the magnetic field in the revolution. So speed of the magnetic field is the NSync. So NSync is equal to 120 FE times with the pole. Okay, so easy yang ni So kita dah ada FE. So this is FE So this is the FE. FE the number of pole 6. Okay, pole 6. So kita just masuk je lah into the equation. Okay, so we get 1000 RPM. Okay, and then the speed of the rotor and the revolution per minute. Okay, so remember the main equation Nm is equal to 1/S NSync. Okay, so this kind of question is related A, B, C, D is related. So once you get the wrong answer in A, so most probably the others will be wrong. Okay, so ini kita buat lah. So kita just masukkan equation 0.035 dapat lah. So kalau kita tengok kat sini NM ni less than NSync So 1000 and the NM is 900 something Okay, and then the slip speed. So the slip speed ni adalah different Okay, the different. Okay, NSync minus NM. So we get that only 35 And then the rotor frequency in Hertz Rotor frequency. So frequency tu senang je lah kan. Dah ada FE. Okay, so then kita boleh dapat lah. So basically yeah, question agak easy The question is quite easy. No need to worry about the explanation, the fundamental issue, no need. Okay, yeah, maybe I will cover the thing. I will try to cover that thing in the revision and also the quiz. I try my best because yeah, it's also important to ask the fundamental issue. Okay, then we go to the induction. Ada soalan apa-apa tak? Atau nak take a rest kejap ke? Ada? Hello?
Macam tak.
Macam ni lah. I think kita stop sekejap. Kita masuk balik dalam 3.13 sekarang 3.8 minit. So 3.13 kita masuk balik. Tak payah keluar lah daripada sini. Just kita akan start balik 3.13. Okay tak?
Okay.
Okay, restkan. Restkan minda sekejap. Penat-penat dulu, relax kejap. Okay, lepas tu kita akan sambung. Okay?